All right, welcome back from that short break. Okay, we are continuing. We had stopped at a point where we're seeing the volume of oil flowing out. That volume, you never see them reading as volume. Usually they read barrels, yes, which are similar to liters. So for us, we stick to liters and cubic centimeters. Volume is measured in meters cubed. So if you have 1,000 cubic centimeters, then this is equal to 1 liter. That's why they say 1 cc, 1,000 cc are equal to 1 liter. This applies to the cars that your parents drive. They tell you that it drives a 4 cc liter engine, 4,000 cc, etc. All these, everything. It applies in almost all environments. So if you're going to work in any field related to that, you must be able to know about the volume that's going to take up. The engines, where the fuel is put inside the cars of your parents, in there, the volume, those cylinders are either cylinder or they are cubical. Either way, we must still get the capacity of those tanks where the oil is put or where the fuel is put. Okay, so we are going now to continue further. Let's move away from there. Let's move away from big things. Let's look at the basic things, yes, inside your compound. So if I go to 4 out of 8 and I look at something smaller, here we are, yes? This is a cuboid, a very simple cuboid. Now, in here, we are beginning with the rectangular prism. If you're using digital science at home, there's a drop down here. You see that drop down? You can change the shape that you want us to look at. If you want us to look at the cylindrical prism, you will find out regular prism, rectangular, hexagonal prism, any of the shapes that you want us to look at. You can see the shapes here. Some shapes you've never heard about, like the hexagonal prism. People have never heard about that, yes? So that's an oblique also. So you can look at that or you can look at any of those shapes. If I'm to look at that one, the oblique, yes? Then let me try to make it bigger from here down by changing it from 5. If I slide to increase its size, yes, yes, making it bigger at that point. Now there, if I stop at that point, you see how the volume is increasing. The volume keeps on increasing, but the concepts remain the same. The base area times the height. So the base area times the height has remained, it hasn't moved away. Even as I was increasing, even if I increase up to the maximum, still all these units change, all these numbers change, but the formula remains the same. So whether you're finding the volume of the biggest tank in the world, or you're finding the volume of your small tank at home, either way, the formula and the concepts remain the same. There's no variation. Let's look at the common tank, which is a cuboid. Yes, if I'm look at a cuboid, rectangular prism. Yes, good. Rectangular prism or cuboid. There we are. This is the big tank, like the tank which is supplying water to the Paul Mienga, up Mienga Tank Hill. This is a big tank. Now, if I have to make it a smaller one, which is like a box which you have at home, which you can use for baking, yes? If I make it smaller, you see that the units, the formula remains the same. Length times width times height. But the volume keeps on changing because the parameters, the units, the quantities on the sides, on the edges, the length of the edges are decreasing. So as they decrease, the volume decreases. The bigger the shape, the more volume it holds. Smaller the shape, the less volume it holds. Now, let's find out from someone who's baking a cake. Let's go to this one. Here we are, delicious cake, birthday cake. Anyone with a birthday, happy birthday from us here. So in this picture, we see a slice of a cake. And this is simply a section of a cylinder. You see that slice? It's just a section of a cylinder. Which section you can find? So you can find the volume of this section as well. Yes? We simply find the volume of this one using pi. Now the volume of the cross section here of a sector here is pi r. It's the angle there 75 over 360 times the portion of the cylinder, which is pi r squared. So that gives us the area pi r squared, the area of that quantity alone, that sector, times a relationship to the whole cylinder, which is pi r squared times h. Yes, good. 9.5 times h. So 75 degrees of 360. 360 is the whole circle forming our cylinder. But we are cutting off just a slice, 75 degrees. So the 75 of 360 is a fraction of the entire cylinder. That gives us the volume of the cylinder. Yes, this is practical. A cake, most of you have tasted cake. Yes. Let's look at another one. Here we are. We have cakes. Sometimes the cakes are cylindrical, sometimes they are square, sometimes they are triangular, they are in various shapes. But in the end, they are all prisms. All cakes are prisms. So Kathy usually makes a fruit cake in 20 centimeter square cake tin. The finished cake has a depth of 8 centimeters. She makes the same cake in a round cake tin with a diameter of 24 centimeters. What would be the depth of this cake? Let's pause here. See that? Before we look at the solution, the volume is the same because the volume you're using in the square, it's just shapes that are changing. The volume in the square trough is the same volume in the cylindrical trough. So the volume we transfer from there should be called the volume we transfer this side. Hence, I can ask you to find the radius, I can ask you to find the height of the cylindrical one, or I can ask you to find the capacity of the square one using the cylindrical one. Either way, these two are related by volume. If you look at both of them, the volume in each is the same. So let me play for you and you see the solution. Here we are. We want to find out the depth H of the cake. The volume is got from the tube, from the cuboid, yes? So the cubical trough where you're putting the cake gives us the volume of the quantity in the cake. Now that volume is going to be the same volume this side for us to get the height. Hence, we go ahead and find the volume as 3,200 centimeters cubed. Always remember to put that power 3. Without the power 3, you're getting something totally different. You're getting length, you're getting area, yes? But this is power 3. Now, for the cylindrical one, the volume is pi r squared times the height. So if we relate the two, we don't know the height, but we know r, which is there, 24 divided by 2. The diameter divided by 2 is our r. So you go ahead and get in terms of h. But these volumes are the same. The two volumes are the same. So if we equate them, end up with our answer as that one. And h is 7.07 centimeters. So you can find out how big, how tall a trough you need to put in the same capacity, the same quantity as you're putting in a square-based trough or in a rectangular trough. So we've learned today, we've learned the volume of a prism. We've learned that volume is cross-sectional area times height. The take-home is cross-sectional area times height, the volume of any prism. Yes? Next time we shall look at a different shape, but for today we'll look at the prism. So whatever the prism, simply get out the cross-section, get the area of that cross-section, the areas of any cross-section, then times the height will give you the volume. That is the basic principle you should take home today. What have you learned from this lesson? Has it been helpful? Do you have more questions? Follow us on Twitter and Facebook. CSTS. Yes, that is CSTS, Cyber School Technology Solutions. You can find us on Twitter, you can find us on Facebook, and then you comment and tell us where you need some guidance, where you need further help. Then you can also find us in Lugogo. Enter the UMA showgrounds. Come all the way up to up to CSTS, Cyber School Technologies Limited. You'll find that at the extreme end of Lugogo. As you enter towards the Coca-Cola depot, you come there, come and see us. Let us help you. Let us give you the DVDs. Let us install this system on your computers so that you'll be able to follow us. Thank you very much for learning from us today.
Thank you for watching this show. I hope you learned a thing or two. Now, if you're a teacher, you'll appreciate the use of digital science and virtual lab. And if you're a student, learning is made simple and fun. Remember, the show is Digital Science for You, and Digital Science and Virtual Lab is the software that can be accessed via Cyber School Technology Solutions located via UMA Showgrounds, Lugogo. You can also follow us on Twitter and Facebook, CSTSUG. See you next time. Allow me to enjoy my coffee.